So this is our first question from the topic. The second set of topic in work energy power, which deals with law of conservation of energy and momentum. So the question says two bodies are having kinetic energies in the ratio 16 is to 9 if they have the same linear momentum. The ratio of their masses is. So let us consider this question by detailing the given parameters of the two bodies, body 1 and body 2, as m1, v1, p1 and k1, linear momentum and kinetic energy, and m2, v2, p2 and k2. It is given that the linear momentum is same, therefore we have p1 is equal to p2, which otherwise gives us m1 v1 is equal to m2 v2. Also, k1 is half. Okay, let's try now. So k1 is half mv1 square, or in other words it can be written as p square by 2m, right? Because kinetic energy is p square by 2m and kinetic energy 1 is p1 square by 2m1. Similarly, k2 would be p2 square by 2m2. Now okay, now it is given that these two bodies have the kinetic energy in the ratio 16:9, which means k1 by k2, right? K1 by k2 is actually equal to 16:9, which is p1 square by 2m1 by p2 square by 2m2. So I can write p1 square by 2m1 into reciprocal of this, which is 2m2 by p2 square. Now it is also given to us that they have the same linear momentum. What does it mean? P1 is equal to P2, which means P1 square should be equal to P2 square, and therefore P1 square by P2 square can be written as, or P1 square can be written as P2 square, right? And therefore P2 square by P2 square would be equal to 1, right? So P2 square by P2 square will be equal to 1, and therefore we get as 2 by 2 is 1, so we get 16 by 9 is equal to m2 by m1, and therefore m1 by m2 will be equal to 9 by 16, which gives us the correct answer as option D, 9 is to 16. Okay, so that was question number 1 in this topic, law of conservation of energy and momentum.